What's up, fellow advanced math fans? Here's what we got going on today. We're going to talk a little bit about hyperbolas. And so we've already discussed a little bit about graphing hyperbolas and how that works. The thing that we haven't done is looking at hyperbolas that are moved around. And so we're going to look at some hyperbolas today where the center is not 0, 0. So we've got to take this thing, move the center around, and make that hyperbola at a different location. And we're going to look at how to handle a hyperbola that's not in the standard form of the equation. And so this is definitely not in our standard form of the x plus or minus the number of the quantity squared over a squared minus y plus or minus the number squared over b squared equals 1. So we're going to have to make this look like that. Now the first thing we need to figure out is, should it be y first or should it be x first? In other words, which one is positive, which one is negative? Now in this particular one, do you notice the y is positive? We've got plus 4y squared. The x is negative. That means we're going to want to arrange this to where the y's are first, the x's are second, because kind of our standard form of the equation, we always put the positive term first minus the other term. And so first I'm going to do is just move stuff around and get all the y's right beside each other at the beginning here. And so I'm going to do 4y squared minus 16y. And then I'm going to get the x's all beside each other. So minus x squared minus 2x. And then because this 11 doesn't really have anything to do with the x's or y's, it's just a constant, I'm going to get it out of the way for now, which means I'm going to move it to the other side. Now it's a plus 11, so if I move it to the other side of the equation, it's now a negative 11. And so there's our first step. Get all the y's arranged together, x's arranged together. And then in order to complete the square, we've done this a couple times with parabolas and ellipses already, but to complete the square, we've got to have the leading coefficient be a 1. Right now, the leading coefficient on y is a 4. So what I'm going to have to do to make that a 1 is factor out a 4. So I factor out a 4 from the y's, and I get just y squared. Remember, factoring is division, so 4y squared over 4 is just 1y squared. 16y over 4 is a minus 4y. And then I'm just going to leave a blank here, because we're going to want to complete the square, so we're going to want to add or subtract a number there. And then let's do the same thing with the x's. Now this is sometimes an easy thing to miss. It almost looks like the leading coefficient here is already a 1. It's not a 1, it's a negative 1. And since the leading coefficient needs to be a 1, I have to factor out that negative 1. So that makes this a positive x squared. And where I had minus 2x, remember I'm factoring the negative out of all of the x's, that's actually a plus 2x. And then again, I'm going to leave a blank so we can complete the square in a second. And I've still got the negative 11 hanging out over there. Alright, now remember, when I go to complete the square, the trick to adding the correct number is add 1/2 of the b term, we called it squared. Now remember, the b term is just the linear term. So we've got our x squared, and remember, any quadratic goes ax squared plus bx plus c, or ay squared plus by plus c in that case. And so our b is just the one on just y, or the one on just x. And so in this case, our b is a negative 4. We're going to complete the square with both the y's and the x's here. So for the y's first, if I want to complete the square, we want to do half of b, half of 4 is 2. 2 squared is 4, so that means I want to do a plus 4 there to complete the square. For the x's, we have 2 for our b, half of 2 is 1, squared is still 1, so I got a plus 1. Now, there's an issue with what I just did there if I leave it at that. You can't just add numbers into an equation because it has to stay equal on both sides. I can add numbers in as long as I do it to both sides equivalently. I know I put a plus 4 here. However, even though that says plus 4, I actually just added 16 to this side. Do you see why it's 16? We've got a 4 here, but we've got this 4 factored out front. So when I put a plus 4, I actually added 4 times the 4 out here. So putting that plus 4 on this side added 16 to that side, which means I've got to add 16 to the other side to keep it equivalent. Alright, I put a plus 1 right here that we need to do something over there to make it equivalent. Now, this is tricky. I put a plus 1, but this is actually 1 times negative 1. Remember, this negative out in front means a negative 1. And so 1 times -1 is -1, which means even though I put +1 over here, I actually subtracted 1. Because 1 times the -1 factored out front is -1. Alright, so let's see if we can go a step farther and factor some stuff down and simplify some things here. So let's work on factoring what's in each of these quantities. So to factor this, I need numbers that multiply together to give me 4 and add up to -4. Well, that would be y minus 2 and then y minus 2 again. Now remember, that's the whole point of completing the square, is when it factors as two binomials, two sets of two numbers, those two sets of two numbers are exactly the same thing, which always makes it come out to a quantity squared. That's good because in our standard equation of a hyperbola, we have a quantity squared. And then minus, let's do the same thing with the x's. We need two numbers that multiply to 1, 1 and 1 would work, and add up to +2, so +1 and +1 would be our go-to there. So we have x plus 1 and x plus 1, or x plus 1, the quantity squared, equals, and then let's just simplify what we've got going on over here. So we've got -11 plus 16, so that puts us at +5, minus 1, that puts us at +4 over there on the right-hand side. Now we're almost to standard form. We need some numbers under these, basically, and this side needs to be a 1. And if we do something clever here, we can kind of make both those things happen at once. If this needs to be a 1, I'm going to divide it by 4. But remember, to keep it in an equation, I have to do it to both sides, so I have to divide this side by 4. Now remember, that means every term of this gets divided by 4. So that means 4 goes under there, 4 goes under there. Now some of this simplifies. Do you notice here I've got 4 over 4? That's really just 1 over 1. And so that becomes y minus 2, the quantity squared. And you really wouldn't have to write this on the bottom. I'm just going to write it kind of for emphasis that this is actually a 1 under there. And then here I'm going to get x plus 1, the quantity squared, over 4. Nothing was there to simplify. And then equals 1. Now we have this thing in standard form. There's the standard equation of this hyperbola. Right. Now a couple things to notice here. I'm going to start to put some information from this into our graph here, and also put some information from this into all of our list of things we were supposed to find as well. Now the center is HK. Now remember, H is always with the X, K is always with the Y. That's an easy thing to mess up because this is out of order, the Y's are first. So H is actually -1, K is +2. Remember, it's minus in the standard equation, so it's the opposite. And so our center is the point -1, +2. I'm going to go ahead and plot that as well. So -1, 2, right here is our center of this hyperbola. All right, so let's see if we can go from there and find some other things. Vertices. Now, something that I think we should discuss before we go to find vertices, does this hyperbola open up and down? Is it like this, or is this a left and right hyperbola? Now, to figure this out, we need to think about which one's positive. Do you notice on this one, y is positive? If y is positive, this is going to be an up and down hyperbola. And so it's going to look like that, which means to get to the vertices, I've got to go up and down. And the amount that I go up and down is a. 1 is a squared. So I'm just going to put some little annotations on here. That is a squared. That means that is b squared. So I want to go a to go from center to vertex. And so a squared is 1, which means a is also 1. And so I'm going to go up 1 and down 1. Up and down because we just said our hyperbola is opening up and down instead of left and right. And so that puts the vertices at -1, 3, and then our other one at -1, 1. So there's our two vertices. Now to get to covertices, we want to go from the center the other direction, and in this case, that's the x direction, and so I want to go left and right b. B squared is 4, which means b is 2. So I'm going to go to the right 2, I'm going to go to the left 2. So right there are my covertices. I'm going to go ahead and write down these coordinates. So we've got -3, 2 for that covertex. This covertex, we've got 1, So that takes care of our co-vertices. Now from here, this is where we made this little box to help graph these. So I'm going to do a rectangle that goes through the vertices and co-vertices. This technically isn't part of the hyperbola. This is here to help us graph the hyperbola. And then I'm going to make a dotted line through each diagonal of this. So we've got a diagonal going through each of the vertices of the rectangle. And so we've basically got that one and that one. And then this is really enough to draw in the hyperbola at this point. Remember, the hyperbola has to open up and down on this because y was squared. It has to hit these vertices, so there and there, and it has to approach these asymptotes we just put in. So I'm going to go ahead and draw it. It's going to look something like this. Go approach that asymptote, go over this way, approach that asymptote, and then the one on the bottom is going to hit that vertex, approach that asymptote, curvy there we go, and approach that asymptote. So there's what our hyperbola looks like. Now we've got a couple more things to do here. We're supposed to find the foci as well. So to find the foci, we need to use the relationship we learned yesterday. A squared plus b squared equals c squared in this case. And so, do you notice we've already got a squared and b squared right over here? A squared is 1, b squared is 4. And so, putting all that in here, I'm going to do this right here in a different color so hopefully it doesn't run into our other information. So using a squared plus b squared equals c squared, we've got 1 plus 4 equals c squared. And so in other words, c squared is 5, which means c is the square root of 5. Now it doesn't come out to a super nice number here, and that's okay. Now here's what we have to think. Every shape we've talked about always opens around the foci. Hyperbola, no different. So it needs to open around the two foci, which means in order to put the foci in from the center, remember c is distance from center to focus, I'm going to have to go up and down that far. And the square root of 5, as far as graphing goes, is real close to 2 1/4. It's not exact, but it's close to 2 1/4. So as far as like estimating, that's what I'm going to think about. So I'm going up 1 2 1/4 approximately to get the one focus. I'm going to go down 1 2 1/4 to get to the other focus. So that's where the foci are. Now, in order to put the coordinates down here a little bit more accurately, do you notice I'm going left 1 still? So the x-coordinate on both the foci is -1. The y-coordinate, well, we need to go up and down the square root of 5 from there. It's not from 0, so a common mistake here is just to put plus and minus the square root of 5. If we were starting at 0, that would be correct. We're not starting at 0. We're starting at 2 units up, and from there, we're going up and down the square root of 5. So here's how I'm going to write that. Starting at 2, we want to do plus and minus the square root of 5. That's the foci. And then transverse axis. Transverse axis is the axis that goes through the center, the vertices, and the foci, which means that's this line right there is the transverse axis. So the transverse axis on this one is left 1 unit and a vertical line. Remember, vertical lines are always x equals a number, and since we're left 1 unit, the transverse axis on this one is x equals -1. All right, that takes care of all that. We've got one more thing left to do. We still haven't found the asymptotes. So that's our last thing here. See if we can find the equation of these asymptotes. Now this takes us back to some thinking about what we did before with y equals mx plus b and finding the slope-intercept form of a line. So to find this, I'm going to do this one up here first. It has to look like y equals mx plus b. So let's find m. M is slope, right? Slope is just rise over run. And so from the center, I'm going to go from the center to this corner of the box. That tells us the slope of this. So the rise, we went up 1. The run, we went over 1, 2. So up 1 over 1, 2. So rise over run is 1 over 2. That means this line has to look like that. Now to be a little more accurate, because we're not done, because we need to know what b is, basically. In order to figure out what b is, we have a point that has to work in this equation. Doesn't the center have to be a point that this diagonal hits? And so since the center goes right through there, I'm going to put that in for x and y. And so I'm going to do 2 for the y equals 1/2, and then for the x, I'm going to put -1 in plus b. And so I've got 2 equals -1/2 plus b, which, just moving the half to the other side, adding a half to both sides technically, I get 2.5 is b. Alright, that means the equation of this asymptote right here is y equals 1/2 x plus 2.5. Alright, so there's the equation of that asymptote. Now let's do the same thing for this asymptote. Now some things will repeat. The process is going to be exactly the same as what we just did. And so we're going to have to start with y equals mx plus b, but for m on this one, we're going from here to here. Do you notice our rise is actually a -1? We went down 1. And then our run is over 1, 2, so our run is +2. So this is y equals -1/2 x plus b. So, again, we know a point that has to work in here. It's the center. So I'm going to put in -1 and 2 for the x and y here, and let's see what we get. So I have, in place of the y, I'm going to put 2. In place of the x, I'm going to put -1. And so I get, in this one, 2 equals -1/2 times -1 is +1/2 plus b. And then subtract the 1/2 to the other side, and I get b in this one is 1.5. So that means the equation for this is y equals -1/2 x plus 1.5. So there's the equation of that asymptote. Alright, a lot going on that one problem. We had to do a ton of work here. You guys will notice that your assignment for today is 3 problems. I know sometimes you get excited, but if you've kind of done math for a while, you realize when there's only 3 problems on an assignment, it's because they all take a long time. And so that's kind of what's going on this one. So we've got a couple problems, and I didn't make all of them. This is like the most complex it gets basically in this. But there's a lot of pieces here. And so hopefully this will help, and you'll remember how to do all these pieces. But that's all the things that we have to put together: the completing the square, using what a, b, and c represent, using a squared plus b squared equals c squared to get the foci, and then using what we know about y equals mx plus b being the slope-intercept form of a line to figure out the equation of these asymptotes, knowing the rise over run for slope, and that they have to go through the center, so that's a point we can use for x and y. Alright, so that'll wrap it up for hyperbolas, and good luck.